See Standard 12th Max, Chapter 6, XI 6.7, Applications of Vector Algebra, Problem 6. See, there's only one problem we are going to do left here. For this, let us see some introduction. Equation of a plane passing through three given non-collinear points. The plane is passing through the three non-collinear. Collinear points is they lie on the same straight line. Non-collinear point, they are not in the same straight line. So in that case, I have taken A, point B, point C, whose position vectors are vector A, vector B, vector C. And P is somewhere here, you can take here, arbitrary point, and also its position vector is vector R. So all these are in our required plane. So in this case, the parametric form of this equation of the plane is given as vector R is equal to A, vector A plus S into vector B minus C plus T into vector C minus A. This is the parametric form of vector equation. Next is non-parametric form. Non-parametric form is given in the dot and the cross product form. Vector R minus vector A dot, take this B minus A, see, sorry, one small correction here. It's not C, it's vector A, then C minus A. Okay, B minus A cross vectors, this vector C minus A is equal to 0. This is non-parametric form. Next is Cartesian form. Cartesian form, that is equal to x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, then x3 minus x1, y3 minus y1, z3 minus z1 is equal to 0. So this is in the determinant form, this Cartesian form. See, three forms you have and three position vectors. So S is B minus A and T here into C minus A. That comes in the cross product, B minus A cross C minus A, then R minus A dot, then Cartesian form. Let me do the sixth sum for you, applying this. See the sixth sum, find the vector form both in the parametric form and non-parametric form, and also Cartesian form of the plane passing through the three non-collinear points, 3, 6, minus 2, minus 1, minus 2, 6, 6, 4, minus 2. So all the three are points. Let me take vector A as here 3i plus 6j minus 2k. Vector B as minus vector I minus 2j plus 6k. Vector C is 6i plus 4j minus 2k. First one is parametric form. So this is vector R is equal to vector A plus S into vector B minus vector A plus T into vector C minus vector A. So we have to substitute here vector A and vector B, vector A, vector. So instead of subtracting this B minus A, C minus A, again let me give you the small simplification. vector r is equal to, you collect all the a vector here. Vector a is here, coefficient is 1, but here the coefficient is s minus t, plus s into vector b plus t into vector c. So now we can substitute here. So 1 minus s minus t into vector a as 3i plus 6j minus 2k, plus s into vector b is minus I minus 2j plus 6k, plus t into vector c is here 6i plus 4j minus 2k. This is the parametric form of representing the equation of a plane where s and t are real numbers are. So before doing the non-parametric form, let me pass on to the Cartesian form. Cartesian form. So that is determinant x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, see all x1s, y3 minus y1, z3 minus z1 is equal to 0. Now we will substitute the values here. X minus 3, y minus 6, z plus 2. Then x2 minus x1. Just you do the calculation here. x2 minus x1. So this is your 3, 6 minus 2 or x1, y1, z1. Then minus 1 minus 2, 6. This is your x2, y2, z2. Then this is 6, 4 minus 2. x3, y3, z3. So x2 minus x1, minus 1, minus 3, minus 4, minus 2, minus 6, minus 8. 6 minus of minus 2 is plus 2, 8. So that you will substitute here, minus 4, minus 8, then plus 8. The same way we subtract here x3 minus x1. So x3 is 6 minus 3 is 3. 4 minus 6, so minus 2. Minus 2, minus of minus 2 plus 2, 0. So you will get 3 minus 2, 0. This is equal to 0. Equal to 0. Okay. Now do the calculation here. X minus 3 into, leave off this row and column, 0 minus 16. Minus y minus 6 into 0 minus 24 plus z plus 2 into plus 8 minus 24. So plus 24 is equal to 0. So x minus 3 into minus 16 minus y minus 6 minus 24 plus z plus 2 into 32 is equal to 0. So you can do the calculation. After this calculation, you will get the equation 2x plus 3y plus 4z minus 16 equal to 0. This is the Cartesian equation of a plane. Next is non-parametric form. Non-parametric form. See, in the non-parametric form, what you have got here? This is vector r minus a. Vector r minus a dot. Then b minus vector b minus vector a cross vector c minus vector a is equal to 0. So this is the form of representing the equation in the dot product. So we are doing the calculation b minus a and c minus a, finding cross both the vectors and then taking dot. Directly you can write from the Cartesian form as I said for you. Here vector or dot, write only the coefficients 2i plus 3j plus 4k. Take this 16 to the other side, so it will be plus 16. So this is the just short form of representing the non-parametric form. So with that, this answer is over. Thank you.